Hello and welcome to today's problem 199 binary search tree right side view. So given the root of a binary tree, you want to imagine yourself standing on the right side and then return the values of the nodes you can see ordered from the top to the bottom. Okay, so given this example, we want to return 1, 3, and 4. That makes sense. With this one, we want to return 1 and 3, and with nothing, we want to return null. Okay, so let's break down what the problem statements is in more detail. So if you're standing on the right side of this, my first thought is just to return all the values on the right side. So go from the root and traverse down to the right, traverse down to the right again, and append all of those values to an array to return that final result. The issue is, however, if you remove 4, for example, and you have 1, 3, 2, and 5, if you're standing on the right side, you'll actually be able to see the number 5 over here as well. So what you'd actually want to return is 1, 3, and 5 instead of 1 and 3. So how do we find a way to be able to account for this? If we just did a traditional traversal only doing the right side, we won't be able to account for any of the nodes that you could see on the right side or on the left side over here. So what we can do instead is use something called breadth first search, which is basically utilizing a queue and appending all of the current node values to that queue and manipulating the values from there. So what I'm going to do is I'm going to start off at 1 and I'll have a queue over here. So we can create a queue in Python like so, collections.dq, and we can append that original value to the dq. From there, I want to loop through the queue and add its children, so 2 and 3, to the queue at the same time keeping track of what level it's currently at. So I have 1, this is at level 1 here, level 2 is 2 and 3, and level 3 is 5 and 4. Basically what breadth first search does is it appends to the queue in level order traversal way. So basically once you reach the very bottom of this binary tree, what'll happen is the queue, if you don't pop anything, it'll be populated with 1, 2, 3, 5, 4 because it does it in level order traversal. So we can utilize this by keeping track of what's the right value and returning those values at the very end instead of the level order one. So we can have that over here. We'll have an array, and then we'll want to return that at the very end. And for now, we're going to want to traverse through the queue, and we want to pop the current item from the queue. So we could do cur equals, let's say like q.pop left, because we want to return the very left value out of the queue, pop that out of the queue. Next thing we want to do is we want to have some way to keep track of the level. So we can do, I guess, the current length. We can figure out what level it is. Well, okay, so we can figure out what level it is or keep them separate by having another loop which only traverses through the current number of elements in the queue which are part of the level. So we can have a length variable. So we're like let's say like queue's length is equal to the length of the current queue, and from there we can then traverse through for we can then traverse through the queue's length, and from there what we can do is we can append those values to the queue. So we'll do q.append the current value dot left, and then we want to append the current values right one. So along with this, we're also going to want to keep track of the right ones because that's what the problem statement is. We can do that by maybe having another variable called curRight. We'll have that set to none for now. And what we can do is keep track of what the right value is by setting curRight equal the current right value. So, right, yeah. And at the very end of that specific level, so you have 1 and you have 2 and 3, at the very end of the level, you'll want to append that to the result array, and you can do that by checking to see, first of all, whether or not that current right value exists. If current right, if that current value exists, then you want to append to the results array, or actually we'll do res.append current right, and then after that we'll return the results array at the very end. And you only want to be able to do these if the current values exist. Actually, yeah. Yeah, right, okay. So, okay, so we'll go ahead and run through the logic again. So, you start off at 1, and you add its children to the queue. So we have 1 over here, we add 2 and 3. From here, we set the current right to 3, and since the length of this will be equal to 2, which is 2 and 3, which is basically the length of the second level, we know that we're going to stop at once we hit that second element, and then we'll return the very right value, which is 3. We'll then move on to the third value, and then from there, you can check to see what the length is. It's 2. We'll hit 4 again. If, hypothetically, the 4 value didn't exist, it'll hit 5 because the very rightmost value will be 5 because the queue's length, or the length of that level at that point will be only 1. So if we go ahead and run this, oh, right, we don't need a length over here. Okay, let's have a look. So output is 1, 2, and 3. Oh, right. We shouldn't be populating this. From here, another thing that's not working is it's not appending anything to here. So we'll take a look here. If cur right exists, for every single thing, we want to set that to the right value. Let's go ahead and, right, while the queue exists, we check to see, we initialize all these values, and for everything in the range there, that's what will do it. Okay, so it's not returning anything right now. Let's have a look why. If cur writes okay, so we initialize a queue with the root as the value. We initialize the results array, which will append at the very end. While the queue has elements in it, we initialize a current right. We initialize a current, which is the very left of that queue. We pop it out. Oh, I see. Okay, actually, we should probably capture the length of the queue before we pop the element. Otherwise, we're not going to be able to accurately get the length. So if we run this again, none type. Okay, so another thing we want to check is if cur exists at all. And if so, that's when you want to perform that. If we go ahead and run this. Right. So for everything here, you want to append the left and the right, and you'll keep popping it. Okay, so we're missing something over here. Oh, right. We want to be able to keep popping the elements while you're actually inside the second for loop, because you want to pop it for the current level. Well, I guess like every single element. Oh, and we also want to include the correct values over here instead of the actual reference to the object itself. Actually, we want to be setting the current right to the current value instead of the right one's value. Otherwise, it'll just return null if the right child is actually going to be null. We want to have it focus on the current one. Okay. Well, so there you have it.